cesi0 with my Pal Rubeus.
Welcome everyone to My Pal Rubeus. This is a talk on taming the three-headed beast. I am cesi0, and we are at LayerOne 2024. 20 years, pretty big deal. This is actually my 10th year, so I'm pretty happy about this too. A little bit about me. I do purple teaming for fun and for a living. Very fortunate to be able to do that. But when I'm not trying to bypass an EDR, I'm either painting minis or petting dogs or working in my cactus garden. A little bit of history. We'll start with going back in time a little bit to 2017 with a tool called cesi0. This tool was released by Gentle Kiwi, who's also responsible for the Mimikatz toolkit, and it is designed to interact and manipulate Kerberos tickets. It was written in C, and it's got a few kind of downfalls, some downsides that make it not necessarily work in modern environments. The biggest thing is that it requires a commercial ASN1 library license, and Benjamin used this in order to work with some of the Kerberos actions and network without having to build his own library. Unfortunately, the version that he included with the release expired in 2021. So unless you buy your own, you're kind of out of luck on that regard. The other downside is it doesn't necessarily work well with PE loaders. So if you're using Cobalt Strike, Empire, Mythic, and insert your C2 here, those are going to use PE loaders to inject into certain processes so that you can load general assemblies elsewhere. And cesi0 doesn't really work with that. So enter Rubeus. It was developed primarily as a simple C# rewrite by Will Schroeder, who goes by Harmjoy, but it really expanded into a lot more. So more attacks have been implemented, more capabilities have been included with this tool set over the years. It's under constant development. Even during my talk, during working on my talk, there were multiple pull requests that were implemented. So this is under constant development. It also implements some work from other authors that are active in the Active Directory and Kerberos attack world. And so those people, some of those authors are listed here. If you're interested in anything Kerberos related, I definitely recommend you check these authors out. A little bit later, we'll have a link to some of their blogs. And so, how do you get to meet Rubeus? How do you get Rubeus for the first time? It's nice to hear about a tool, but where do I get it? Pretty straightforward. You check it out from the GhostPack Git repo, and then you've got a source code. They do not release prepackaged binaries because it's too simple for antivirus vendors to create signatures. So optionally, once you pull it down, you might want to modify some of the function names. You might want to, so one of the ways that I was able to bypass the protection that my corporate environment has is by simply adding an icon to the project. And so by default, it doesn't have an icon associated with it. And so I just went online, downloaded a random icon, included it with the project, and all of a sudden the antivirus is like, all right, you're good to go. After you've done your modifications, it's pretty straightforward. You just go to build, and it creates your executable within the project directory. So before, you guys can read this. Before we get into some depth, we'll go over some key terms that will be referenced throughout the presentation. The first one is the main management server. It is the key distribution center, and it's responsible for issuing, managing, and validating all of the Kerberos tickets across the environment. There are a few different types of tickets. One type is called a ticket granting ticket. And we're going to hear a lot of tickets over the course of the presentation. But what this is a temporary ticket that allows you to request additional tickets. So this is your primary ticket that from there you can then request additional tickets to other services. The next one is going to be a ticket granting service. And that is the individual service that you can then authenticate to. And this also handles ticket requests. And so once you ask the ticket granting service for a ticket, that will give you a ticket to the individual service itself, which is called a service ticket. And so that service ticket grants you access to the particular service that you've requested access to. That service that you've requested access to is uniquely identified in the KDC and Active Directory by a service principal name, SPN for short. And so that's just a name. It contains the service name and the host. And so that way you can uniquely identify that instance across the domain. So if you've got a single server that has multiple MySQL instances, for example, you'll have MySQL service 1 / then the host name, and then for the second service you'll have MySQL 2 / and then the host name. And so these are ways to distinguish between individual services across the domain. The next term is the privileged account certificate. And this is a Kerberos extension that was implemented that allows for authorization information to be sent across. So originally Kerberos would basically only validate whether you had the correct key, the password. What this extension does is it includes group information, login and other membership information, so that way the service can actually validate whether you've got appropriate access, not whether you're a valid user or not. And this information gets sent along with the ticket itself. The next term is the authentication server request. And this is basically just the initial application for the ticket. This is, hey, I'd like a ticket, can you give me one? It's important to note that this is encrypted with the hash of the user who's requesting it, their password. The next one is the response or the reply. And that is the authentication server response, known as the ASREP. And that's the reply from the KDC. And it's important to note that this has a portion of the message that's signed with the user's password. So in order for the person who's requesting it to be able to read it, it needs to have the right key. And so this is signed with the client key so that the client can then open it and read the data. Next, we've got the NT LAN Manager, or NTLM for short. And this is the legacy protocol which was introduced in Windows NT that provides authentication for Windows. Kerberos is considered the predecessor or successor to that. And one of the major downsides to still using NTLM is that the NTLM hashes are using MD4 or RC4, which is the different names for the same hash. But it's at this point it's considered weak and can be cracked easily using password guessing tools. And so it's generally not used across modern environments. However, it's still used because of legacy applications. The next item is the KRB TGT, and this is the service account that runs the Kerberos ticket granting service. Think enterprise admin. So this is a service account that if you compromise, you can use that key to essentially issue any type of ticket request you'd like. And the last term is a colloquial term known as an offline attack, and that's just to reference any attack that doesn't communicate directly with the KDC. And so we'll get into some sort of attacks that are completely offline. So, we've got over some of the boring stuff. We've got we've got Rubeus, we've got access to a system. What do? Well, welcome to the ER. We're going to triage you. The first thing we do is we run the triage command, and the triage command looks in memory for all the ticket granting tickets that are stored there. And so if you've got multiple users on the system, you can see each ticket for their system. Well, this is a little bit blurry, but so we've got the table here, and the table has 4 columns. On the far left, we've got the LUID, which is the locally unique identifier. We've then got the username, the service, and finally the end time, which is the time that that ticket expires. If you look to the blue line on the top left, where we've got a LUID, which is very hard to read on this screen, but it says 0x3E4. And in this case, this represents the network service. The network service is a local user account that's often used to run services that need access to network resources. We then have a red line pointing to another LUID, which is 0x3E7. And that represents the system user, which is another local system account that runs services. And basically, if you install a service on your machine and you don't specify a explicit service account to run under, if it needs network access, it's going to run under network service. If it doesn't, it's most likely going to run under a local system. And while it says locally unique identifier, these IDs will remain consistent for these 2 accounts across all systems. We then have some other LUIDs that are associated with different users on the system. And so we've got here a user that's a local, that has logged into the system and so has its ticket cached. And then we've also got a bunch of tickets for the SQL service account, which is the account that this happens to be a SQL server, and this is the account that the SQL service is running under. So as I said, if you don't specify a service account, it'll run under one of these other ones, but in this case, an explicit service account has been specified, and so it's using that. We have an orange arrow, and that's pointing to this first service. And again, hard to read, but that says KRB TGT. And anything where you see a service that says KRB TGT, that's going to be a ticket granting ticket. And so that's the type of ticket, again, that allows you to request other types of tickets to individual services. And so that's what most of the rest of these are. And so the green arrow is pointing to one in particular, which is the LDAP service on the domain controller. And so what that allows this to do is it allows the network service to be able to query the LDAP service using this particular service token. Now, if you've got particular users that you want to target, you can specify them in the parameters, as well as LUID or a particular service or server. So once we've listed all the tickets, what do we do with them? Well, let's dump them. So again, like the triage command, you can specify an LUID, a user, a service, so that you can just pick out the individual ticket that you'd like to dump. And in this case, what we're going to do is we're dumping the LUID for the SQL service account, and we're going to specify the KRB TGT service because we noticed that it has a bunch of different tickets that it has already requested. And so what this does is it scrapes from memory the ticket, and you can see the information here regarding the service name, the username, and how long it's valid. And then down at the bottom, you've got this giant base64 encoded blob, which is an output of the ticket. And so then we can take that and potentially use it at a later time. Now, what happens if you get onto a box and the user that you want to target hasn't connected, that their ticket's not in memory. What are you going to do? Well, Rubeus has some really nice capabilities, and one of the capabilities is the ability to monitor. And what this will do is it will check every X number of seconds and scrape memory and grab new tickets. You can specify a target user if you're looking for a domain admin. You can also specify a registry flag. And what this does is it allows you to do some sort of output, some logging. By default, it doesn't. You can't necessarily dump it to a file, and so you can dump all the data that you're collecting from Monitor into a registry key so that you can then access that data later. You can also explicitly tell it how long to run for. So if you are potentially, that an antivirus scan gets kicked off every 24 hours, you can have it run for 12 hours and then stop. Now, the other option is Monitor Plus. It's the ability to harvest. And what harvest does is it will look through memory every X number of seconds, but if it sees a ticket that's about to expire, or by default is within the next 20 minutes, it will automatically issue a renew request for that ticket so that you can use it without it expiring, because you have to issue, once a ticket expires, you can't renew it, you have to get a new one. And of course, this is limited by how many renewals are available and how long it can be renewed for. So what we've got here are some screenshots of the monitor and harvest commands running. At the top, we've got the list of parameters that they can accept. They're pretty much the same. The only difference is harvest has a monitor interval and a display interval. And so the monitor interval is how long it will check, how long before it checks the memory again. And the display interval is how long before it shows it on the screen again. Where monitor just has interval because it's only displaying things. You then have on the left side the initial run. And so basically when you start it for the first time, it'll say, hey, I'm going to check every, in this case, 60 seconds, looking for new TGTs. And here's what I found so far in memory. Well, on the right side, we've got 10 hours later. And we have a user that is now logging onto the system. And because they've logged on and we're now monitoring the system for any keys in memory, we've explicitly grabbed it as soon as they log in. Okay, what if they're not going to log into the box? What if, this admin user just isn't going to log into that box? You can't grab their TGT that way. What other options do you have? Well, how about just requesting a TGT from the KDC? So in this case, what we can do is we can specify using the ask TGT command, we can explicitly specify a user, and then we can use either a password, if we've got their plain text password, we can use that, or if we've got a hash that we've stolen through some other means, if we've gone onto a system and we've done a hash dump, or if we've been able to compromise their key another way, we can explicitly specify either a DES hash or an RC4, which again is the NTLM hash. We've got the AES 128 and 256. We've got a bunch of other parameters which we're not going to go over now. We're going to go over a little bit later. But one of the more interesting parameters is the OPSEC one. And there are some distinct differences between the way that Rubeus issues TGT requests versus how standard modern systems do it. Now, the TGT is still valid, it still works. However, if you're trying to remain super stealthy, you might want to specify the OPSEC command. And what that does is that goes through the actual process of requesting the ticket and then replying and going through the whole back and forth, as opposed to in this case, just bypassing it and getting the TGT by itself. And so it's important to note that this is only available if you use the AES 256 hash due to it trying to remain stealthy. And if you're trying to request RC4 hashes, that's generally going to be a method of detection. You can also specify a certificate. So if you've got access to their certificate store or you've exported their user certificate, you can use it that way. Alternatively, you can, if you've located a user that doesn't have Kerberos pre-authentication enabled, you can simply request a TGT on their behalf and by just specifying the username. And we'll go into that a little bit later. And then the last thing is you can simply request a standard service ticket, which in this case isn't going to be a TGT, and that is directly to a service itself. So that would be not a TGT ticket, but a service ticket to an individual service. And so the attack where you use the user's NTLM password or NTLM hash to request a new TGT is called overpass the hash. And so what we're doing here on the top is we're basically just specifying the domain. We've got the user, in this case, a domain admin, and then we've got their NTLM hash. And then what that does is it requests a ticket from the KDC using the RC4 algorithm. And then right here, we've got the giant base64 output of the ticket. Now again, NTLM isn't the preferred method of authenticating to modern servers, so most SIMs have a built-in detection for Kerberos ticket requested with RC4 authentication. And so if you want to get around that, what you can do is you can specify another hash. You know, the modern systems are going to use an AES 256 hash, and so what you can do is you can also specify their AES 256 hash. Alternatively, you can just specify their plain text password and then tell it what type of hash you want it to automatically generate. And so Rubeus, if you give it a plain text password and give it the AES 256 flag, it will automatically convert that password into AES 256 format and send it off for the ticket request. Okay, so we've got tickets. We've either dumped them, we've requested them. What do we do with them? Well, we pass the ticket. And the way that you do that is by issuing the PTT option in Rubeus. And you just take the giant base64 encoded ticket that it outputted from the previous commands, and you issue it with the /ticket parameter. Alternatively, you can use a file. But if you're working with Rubeus, it's often the case where you're just going to be copying from one output to the next input. And then down here, we've run what's the klist command, which will list the active Kerberos tickets in the session. And so we can see we now have the ticket of that particular user within our session. Now, if you have a ticket already in your session to that particular service, if you import your new one, you're going to overwrite the old one. So you may not necessarily want to import it into your current session. So what you can do is you can create a sacrificial process session using the create net only command. And what that does is it creates a new process under a different user, which means a new LUID, which you can then pass the ticket to that particular LUID using the LUID parameter. And what it'll do is it will import that ticket into that session, and then you can use other tools to either steal that ticket, or you can have that process show up and you can use that as an interactive window. It's important to note that you cannot pass the ticket to an alternate session if you're not admin. So if you're not an admin, that may not be an option. For the create net only command, what this does is it emulates the run as /net only Windows command, which creates a local login session, which you can then import your tickets into. And you can specify a user and a password, but this username and password isn't going to be used to authenticate to anything. So in this case, I just didn't specify username and password, and so it generated one randomly because I'm not interested in using it. All right, so let's go a little bit back to basics regarding how a user might connect to an individual service. So if the user wants to connect to a particular service, known as an SPN, it needs to request a service ticket from the ticket granting service. So it's also important to note that requesting this ticket doesn't grant access to the user. The target system is supposed to perform PAC validation upon the connection to determine whether the access should be granted. So basically, just because it has a ticket doesn't necessarily mean it has access. The service should check the PAC info, which contains authorization and membership information, to see whether access should actually be granted. And then it's also important to note that the service ticket gets encrypted with the hash of the target service account. So what we can do is we can request a service ticket explicitly saying we want it to be an RC4 encryption type. We can then extract the hash of the service account that it's been signed with, and then we can take that to an offline tool and perform password cracking against it, effectively guessing the password for that account. And this is known as the curb roasting attack. The next attack is sort of similar. It was actually discovered and presented here at LayerOne 2015 by Jeff, so shout out to Jeff. I don't think he's here though. But his talk, Kerberos Party Tricks, Weaponizing Kerberos Party Protocol Flaws, discovered that the AS rep ticket, which is the response ticket, it's encrypted with the service key of the KRB TGT hash. And the AS rep, there's an encrypted portion of the response that's signed with the client key so that the client can read it. Now that client key is the hash of the user. So there's an option in Windows where you can disable Kerberos pre-authentication, and if that's disabled, what you can do is you can send a request for that particular user, you can extract the hash from the response, and then, much like the Kerberos attack, take it to a password cracking tool and crack the password for that particular user account. Also to note, if you've got permissions over that account, if you've got the ability to, in this case, perform either the generic write or generic all over the account, you can change certain parameters, in this case, the Kerberos pre-authentication enabled, and you can disable that. You can then run your attack, and you can re-enable it for that user so that hopefully no one else compromises that user. This is called AS rep roasting. And so, just brief review. Basically what you do is you look for users that have pre-authentication disabled, which is basically just this little checkbox on their user account. You run the AS rep roast, grab their password, crack it, and you're good to go. Hopefully you can see this, but here's a demo of the curb roasting and the AS rep roasting. And so the first thing we're going to do is we're going to simply run the curb roast command on the local domain. And what this does is it searches for accounts that have the RC4 enabled for their account, and it requests a ticket and extracts the hash of those particular users. We then take those over to a password cracking tool, in this case Hashcat, and run it against the RockU word list, and in less than a second, we've got a password for one of the users. Now, again, this password was weak, and so you may want to avoid this. Now we're going to run the AS rep roasting attack, and this looks for users that have Kerberos pre-authentication disabled. It will then request a ticket, grab their hash, and then we can do the same thing that we did before, bring it into Hashcat, and we can run the RockU word list against it, and we can attempt to crack it. And in this case, we are able to crack a user's password so that we can gain access as this particular user. So yes, now granted, this is based on a word list attack, and so one of the defenses against this would be to have very strong passwords. Now, you can also run the curve roasting attack against accounts that have AES 256 enabled. However, that is a modern algorithm and is going to take significantly longer for you to crack the password. So in this case, it was like 1 or 2 seconds. If it was AES 256, it'd probably take 2 weeks. Next topic is called unconstrained delegation. And this is a feature that was introduced in Windows 2000 as a way for services to delegate Kerberos access to additional resources on behalf of the user. So imagine you've got a web server. That web server needs to connect to a database server that hosts the database in order to access the data. Well, the user is only going to authenticate or connect to the web server. And so in order for the data to be collected from the database server, the initial server, the web server, needs to request access on the user's behalf. And when this is enabled, the KDC includes a copy of the original user's TGT ticket inside this other TGS. It will then cast the user's TGT so that it can request additional resources at any point while the user is active. So if we compromise a host where unconstrained delegation is enabled, what we can do is we can sit on the host, we can then issue the monitor command, and we can wait for users to authenticate, steal their tickets, and use them against other services in the domain. Microsoft realized that this might be an issue and decided that maybe we shouldn't be storing other users' TGTs in memory. So they introduced a set of Kerberos extensions known as the S4U or Service for User extensions, and these consist of the S4U to self and S4U to proxy. The S4U to self is responsible for allowing a service to obtain a service ticket to itself. Now, why would you do this? Well, oftentimes, in the case of a web server, users aren't going to present their Kerberos tickets to the web server. They're going to authenticate using usually username and password, maybe a single sign-on, and so that's not going to be Kerberos. And so what the service then needs to do is request a Kerberos ticket on that user's behalf. And so it can talk to the KDC, say, hey, I want a ticket on behalf of this other user, and then run the commands that it needs to do and give the output to the user. The next extension is the service for user to proxy. And what this does is instead of granting a ticket to the local service, it allows you tickets to other services. And so if we go back to the scenario where we got a web server and a database server, what this does is the web server will request a ticket for access to the database server. And so if we look on the top right, what we can see here above the dotted line is going to be the S4U to self transaction. So basically, user requests something from Service 1, Service 1 talks to the KDC to get a Kerberos ticket to itself, it then runs whatever it needs to run, gives the response back to the user. Below the dotted line, we've got the S4U to proxy. So user requests data from the web server says, hey, I need a ticket to the SQL server, the KDC says, go ahead. It then connects to the SQL server, gets the data, and presents it back to the user, as if the user originally requested it itself. Well, there are some inherent issues with this. So, introduced in Windows 2003, Constrained delegation was implemented as a safer way for services to perform delegation. So instead of the service being able to request a ticket to any other service, what this does is it limits the services that can request tickets to. It utilizes the MSDS-allowed to delegate to attribute, which within either and this can be configured on either a user or a computer account. So within either the user or computer account properties, you've got this attribute that will specify which services this other service is allowed to delegate to. And as you can see on the top right, we've got a screenshot of how you do that. It's a simple property window within the properties of the object. Shout out to Alberto Salino for discovering this account, or this attack. And so let me go over it. Basically, a service, so to recap, or to break it down, a service validates an inbound ticket by ensuring that it's encrypted with that service's ticket. So if it's encrypted by another service's key, then it can't read it, and so it's like, hey, I'm not going to do anything with it. So the first thing that it does, it validates that it's encrypted with that service's key. Now, it's important to note that that key is derived from the password hash of the user running the service. And as I discussed earlier, as most services, unless explicitly specified, are going to be running under the system context of the computer account, which means all of the service tickets are going to be encrypted with the same key. Well, also when performing ticket validation, the SPN doesn't get checked, is not encrypted, and can be modified. So if we have all these pieces, what we can do to exploit constrained delegation is we can specify a user that we want to impersonate. We have the SPN that we can delegate to. We parse the property. We have an alternate service that we want to connect to. And then the TGT of the delegating either user or service. So if we put all those together, what happens is we initiate an S4U to self request to service A, where we've got legitimate access, we're able to delegate on behalf of that service. We then modify it because we have the key, we know the system password, and so we're able to modify it. We then change the SPN so that we can connect to another service that we want to connect to, and then we issue an S4U to proxy request to ask the KDC to give us a ticket for this new modified request. The KDC says, sure, looks encrypted, looks fine. You can now connect to this alternate service. And so you can elevate your privileges from one service to another using this technique. The next attack is known as the silver ticket attack. And by using the hash of a service account, basically a forged either TGS or TGT can be made that allows you to impersonate any user to that service. So basically, you've got the password for that service. You can issue tickets to any user to that service. You can, in order to build your ticket, you can query Active Directory to grab the pack info. So basically, you do a lookup for you look up that user and it automatically builds all the authorization info. Alternatively, you can build it by yourself. So if maybe perhaps you know that a particular group has access to a SQL service account or a SQL server, you can add that to the pack. And you can say, this user is part of that group. And you can then forge the ticket. This is done completely offline. It does not communicate with the KDC for the request. However, when you use it, it does issue a response. And so this opens up a detection opportunity where you can look for tickets that have a response but don't have an initial request. And this is often used in order to detect silver ticket attacks. Next screen here we have is a screenshot of a silver ticket attack being initiated. And so at the top, we are issuing the silver command, a particular user, in this case, domain admin. We are looking to LDAP to build the pack info. We are specifying the service that we want to connect to. We've got the RC4 hash of that particular service. We then list the SID, or the security identifier, of that particular user. And then we do no wrap, which allows the base64 encoded ticket to be on one line for easier copying. And then we pass the ticket to the local session, because that's what I was doing. And so at the top, the red box is the section where it's querying LDAP for the pack information. And so what it'll do by default is it'll use the local user context to query Active Directory, see if that works. In this case, I was running under system, so it didn't. But then it fell back to anonymous access, and so it was able to grab the pack info, which is listed in the second section. And so that lists the domain, the user SID, the user ID, the groups that it's a part of, as well as additional information. We then have the ticket creation, and then at the bottom we have the ticket data, which is the valid to, valid from, renewal, and then the output of the ticket itself. A variant of this attack is called the golden ticket attack, and it is more limited in scope, but it is essentially the silver ticket attack where you're using a stolen hash to request new tickets to any user that you wish. And so in this case, the golden ticket attack is using the hash of the KRB TGT service to request TGTs on behalf of any user. So again, those TGTs allow you to request tickets to other services. And so if you've got a TGT made by the KRB TGT service, you can then request basically anything. And this is, again, this is a targeted silver ticket attack against the KRB TGT. And one interesting thing to note is that you can also run the /show command for the golden ticket, and it'll output a giant string command that is basically the silver ticket command that allows you to run this attack using that other option. And another important thing to note is that the silver ticket attack can request or can create TGTs and TGSs, where the golden ticket attack is just TGTs. And so what we've got here is a screenshot of the golden ticket attack being run. And as I said, it is almost identical to the silver ticket attack, which is why it looks almost the same. The golden ticket command is being run with the AES-256 hash of the KRB TGT account. We then specify the user that we want the certificate for, the domain, we tell it to query LDAP to build the pack, and then I issued the print CMD command here and then realized it was the size of my slide and did not include it. And so again, like the silver ticket attack, it queries LDAP for the pack info, builds the pack info, creates the ticket, and then it gives you the ticket at the end. And the way that it's able to build these tickets is by requesting the ticket, decrypting it using the key that we've provided, and then modifying the information, and then re-encrypting it with that key, and sending it on its way. And because this is the key for the KRB TGT account, it's identical to what the KDC is going to be performing. The next variant on these attacks is known as the diamond ticket attack. And again, this is very similar to the last two. However, it's a little bit different. It uses the hash of the KRB TGT account and forges a ticket for any user in the domain. However, what this does is it requests a legitimate ticket, it decrypts it, it modifies it, and it finally re-encrypts the ticket. And so this is, oh, I'm sorry, the golden ticket did not re-encrypt it. The diamond ticket will take the other one and it will modify it and re-encrypt it. This also gets around the detections for the golden and silver tickets because it actually produces a valid request. And so if you're looking like for tickets that don't have a valid request, you're not going to see this one. One of the ways that you can detect this is by looking for oddities as far as how long the ticket's valid for. So by default, the Kekio function for building the diamond ticket attack had the ticket valid for 10 years, which is unheard of in a corporate environment. So if you do research and figure out how long a ticket's supposed to be active for, you can blend in to the environment. Also, this is less prone to forgery mistakes because you're actually requesting a ticket and modifying it and re-encrypting it. Now, the other tickets that Rubeus creates are valid, they work, but all it takes is one bad switch for you to create a ticket that it will blow your entire engagement. And so what we can see here is the diamond ticket attack being initiated. And so we specify the diamond attack, we've got the domain, we've got the user that we know their password to. And so this is actually the user that we previously curb roasted. And so we've got their password. We specify the domain controller. We specify the user that we want to steal their ticket, their pack info. And so in this case, what we're doing is we're specifying a domain admin. So we're going to elevate the privileges of this regular user to a domain admin. We then specify the RID of the target user. We can specify additional groups. So in this case, I specified 512, which is domain admins, but it's not necessarily because this user is a domain admin already. But what you could do is choose 519, which is enterprise admins, and potentially elevate your access to the entire forest. We then specify the encryption type because we specified their plain text password. So what this is going to do is Rubeus is automatically going to hash the password and into AES 256 so that it'll send it off. And then we've got the Kerberos encryption key at the end so that the ticket, so that Rubeus can take the ticket and modify it using the encryption keys. So what we have here is building the initial request for Jon Snow. And so this is the initial ticket that is valid from the KDC. We then decrypt, modify the pack information, sign it, and re-encrypt it. And we've got this new key, which is still valid for the same user, but has additional access. And then what we can do is we can take it over to our attack box. We can use the in-packet tools to convert the ticket from a what's known as a Kirby ticket. And this is what Rubeus outputs, but Linux likes to work with Ccache tickets. So we're going to convert it from a Kirby to a Ccache ticket, where they're going to export it as a local variable and then run the in-packets secrets dump tool to dump the NTDS from the domain controller. And what this is doing is it's using our Kerberos ticket that we've used, and we can see that it's starting to dump the local SAM hashes. And so what we've done is we've escalated our privileges from simple regular user to a domain admin account, where we can then dump all the passwords for every other user on the domain. So if you're interested in anything else, Kerberos related Rubeus and Active Directory, I definitely recommend you check these resources out. I feel like I've only scratched the surface on Rubeus, even on some of these commands. I genuinely feel like you could probably spend an hour just on the silver command. There are also commands like brute, where you can run a brute force on Kerberos accounts. You can also renew the tickets. There's a function where you can actually change the password of the user if you know their ticket. And so the first place I'd recommend you reading is just the README. And so the README is up on the GitHub, on the GhostPack repo, and it is extensive. And every time they add a new feature, they update the README as well, so it is a good resource. The next site I'd recommend you check out is Harmjoy's blog. And so this is where Rubeus was released. And he is active in developing, researching, and exploiting attacks for Active Directory, Kerberos. He was an excellent resource for developing the presentation and just general information as well. The next site is exploit.ph, which is run by someone who goes by exploit.ph, who is also a heavy contributor to the Rubeus code base. He implemented some of the constrained delegation stuff, and is also a great resource for Active Directory and Kerberos. There's also Elad Shamir's site. Again, also a contributor to Rubeus. It seems like most of the people who are contributing to the attack space are also implementing these in Rubeus. We then have the Spectre Ops website, or I guess blog, and that is always a good resource for information. And they also delve into other things, not necessarily Kerberos and Active Directory, but attacks in general and defense. And then last, we've got Sean Metcalf's blog at adsecurity.org. And again, these sites provide deep dives into Active Directory and Kerberos attacks. And do you have any questions? Yes. No, behind you. Okay. Yeah. Mm-hmm. I'm sorry? No. So he asked whether you can dump the memory from user space, and so if you're an unprivileged user, you can dump your local tickets. There's actually also a trick known as the TGT delegation trick, where you can get a ticket for your user using the GSS. There's a hidden Windows API where you can actually get a valid ticket for yourself. Yeah. There are also other ways in order to elicit things to connect to your server so that you can then steal the ticket. But yeah, having system or admin access. Yeah. All right. Well, closing is in a few minutes, so hang out, and thank you very much for your time.